All right, so today's lesson is on 7.1, expanding algebraic expressions. Everything we're going to do this chapter is all about algebraic expressions. Now here, after we watch this little video, I'm going to see who knows the difference between an expression and an equation. So here's our little launch video.
In this topic, we will be taking an in-depth look at algebraic expressions. We will learn when and how to expand an algebraic expression. And no, that doesn't mean the expression gets larger. We will also find out what expanding an expression can help you do. Along the way, we will look at how a common factor can help you rewrite an algebraic expression. And finally, how different forms of an algebraic expression help you solve a problem. It's going to be a busy topic. So what do you say we expand our math horizon a little and get going with algebraic expressions?
Yeah, they try to make a joke. So when we talk about an algebraic expression, does anyone know what the difference between an expression and an equation is? Ty?
An expression, well, I haven't done this unit
Use the
before,
handheld sharpener. Yeah, that one doesn't work. Just use the handheld.
From what I've seen now, I think an algebraic expression is something where you can like insert a number and another number will come out.
It doesn't have to be, but you're right. That can be an expression. Alex?
Wait, an algebraic expression?
A lot of what we're doing this year is algebra. So that goes back to kind of when we used to separate algebra and geometry more. Algebra is more dealing with equations and numbers and variables and all that.
Yeah, variables.
So what is the difference? So I guess I can flip my question. What does it take to make something an equation?
It has to equal something.
Has to have an equal sign.
Yeah.
An expression has no equal sign.
Oh.
So that's what, when we talk about expressions, it's a mathematical statement using numbers and maybe using letters that doesn't have an equal sign involved. So I'm going to give you an algebraic expression. I'm going to give you negative 21w. I want to know if you can create at least 3 other expressions that when simplified or combined will equal negative 21w. So try it on it. You can only use these symbols that you see on your paper. You've got addition and multiplication. You've got some parentheses. You've got a w. You've got a 7, a negative 21, and a negative 3.
Got one. To make negative 21w.
To make negative 21w, yes.
What?
So Alpha, you just said that you have one. What operation did you use? Multiplication. What did you multiply?
Negative 3 times 7w.
So Alpha said if I take negative 3 times 7w, well, if I have 7w and I multiply that 7w by negative 3, it'll equal negative 21w. What else? How else can I do this? Todd?
I'm thinking you can do negative 21. Well, no, negative 21. You see what I'm talking about?
Yeah.
I'm doing that parentheses negative 3. Or wait, no, I take that back. I meant 7 parentheses 3.
7 parentheses,
Yeah.
the negative 3, what next?
Put another parenthesis.
Close the parentheses.
Yeah, and then equals 21w.
Ooh. Do I have a w over here yet?
Oh no.
So we still need the w, right?
Yeah,
But I can drop the
yeah,
w right there.
W
And it's
equals-
That's good. We don't need to put the equals to leave it as an expression.
Mhm.
This is 7 because there's nothing between the number and the parentheses. That tells me to multiply.
Yeah.
So if we wanted to, we could show the multiplication. 7 times the parentheses negative 3. But either way, it's going to multiply. 7 times negative 3 gives me negative 21, and then times w gives me the negative 21w.
Yeah.
Right?
Kind of like the reverse.
Will make the number positive, correct?
Incorrect. That would be if we used, what are the bars called?
Oh.
Stick bars.
Sticks.
Big sticks.
They were up. My poster fell down.
Value.
Absolute value. So there's a big difference. Parentheses are just grouping symbols. Brackets are just grouping symbol. Absolute value would make it positive. But those are just the bars. Yeah. I do, only if you'll give it back to me. Bright pink. You can remember that was mine because it's bright pink. All right, anyone have another one? We want at least one more of these. Alex?
Well, it's not really one. It's kind of, well, I don't know if you would allow this, but you could like flip it, saying like 7 times -3.
We could. So we could also just say 7 times the -3w, just like we had -3 times 7w. Alex just kind of applied the commutative property. We could have also just said 7w times -3, and that would be totally using the commutative property because I just flipped the order. Nick?
-3w times 7.
Yeah, we could do -3w times 7. Here's one that I was wondering to see if somebody would figure it out. If I do -3w plus -3w plus -3w, and I can keep going until I get 21. Now I would have to do this 7 times, so I'm going to run out of screen. So I'm just going to put plus ... to say we would keep adding, but we've ran out of screen. So that's all the time we can spend on the warm-up for today. So make sure you have a couple of these written down. You need a couple of these expressions. I would write down probably these two. Another one that we didn't necessarily get to was I could open my parentheses, do the -3 times 7, and then close my parentheses and have w. Yeah, so your parentheses can go a variety of places. I have a question for you guys. What would happen if I had -3, then my parentheses, but accidentally put 7 plus w? Talk to all you guys. Ben, we haven't talked yet today.
Might not be correct about this, but I'm pretty sure that the W would have to resemble a number of some sort.
Mm-hmm. So, I think what you're thinking about is the fact that I have to do parentheses first. Yeah, like order of operations. So according to order of operations, I have to add this first. Now, if I have 7 of something, can I add w to my, say I have 7 candy bars.
Okay.
Can I add w more candy bars?
No.
So can I add it? No. So we can't do this addition. That's where
we split the 3 and the w, and because we can't do 3, well, we can do 3 times w, but it wouldn't equal a number. It'd be -3w, and then we would have it plus whatever we would get when we times 7 times 3.
Ah, so this is where we bring in our distributive property. So when you have a number right up against parentheses, it tells us to multiply.
Yeah.
But what happens when I have multiple things?
The algebraic
inside?
expression 3 times the quantity x.
So, I can talk way cooler than him if I need to. We have this. The algebraic expression of 3 times x plus 2. So, it's a product of 2 factors. Here's what it means. Product with 2 factors. What's product mean?
Product is the answer to multiplication.
Hey, look, a hand. Miriam.
A product is an answer to a multiplication equation.
So, expression. This tells me to multiply. However, I can't add these together. Todd, stop playing with the calculator. Give me your eyes. So since we already talked about the fact that I can't add these 2 terms that are non-like, they're non-like terms because this is a variable and this is a number. here's what we do. And on your paper, this one's done out for you. So this is right here in the boxes where it says the distributive property. Watch what happens. This 3 has to multiply. I need your eyes up here because nothing's going to happen on your paper. So instead, we say, okay, we got 1 factor out front, 2 factors here. I want to figure out what the sum is going to be, but how do I get to this? There's not like some magic that happens. This is what we do. We take our expression. Well, it changes the expression here. Yeah, so I'm going to pull up your notes really quick, actually, and so that you can write down the expression if you want. Here's what happened in your notes, and this is why I didn't totally love how digits had it. Over to either down here or up beside distributive property, I would write 3 times x plus 2. The first step.
Is that a, like, right
Yeah,
in front of the
that's a plus.
Yeah, it shows that.
The first step you always do. This is going to be a test on your mastery. The first test the first step we always do is to draw something. We don't do any math. We don't even have to think. All we do is draw an arrow from my term out front to every term inside. If there's 5 terms, we're drawing 5 arrows. Here, there's only 2 terms in my parentheses, so we're drawing 2 arrows. Miriam?
So you would times 3 times x and 3 times 2.
Yeah.
So we get 3 times the x plus 3 times the 2, and that's how we get 3x plus 6. That's it. So here it shows you another one where they have -2 times -3y plus 5. So they draw the arrows first. Then they show my first multiplication is my term out front times my first term. My second multiplication is that term out front times the second term in the parentheses. And then I do the multiplications. And I still cannot combine because they're still not like terms. Questions, comments, concerns about any of this? Cool? Okay, so we're going to try these 3 examples. Let me check. I think I have more space if I come over here. I do not have more space. Might as well bounce back to the notes. First thing you do.
Ooh.
What is it? Sorry, pointing at you looks like I'm pointing at Braden too. Yeah, draw the arrows, right? Everybody should be drawing arrows. Now, here's the thing. Somebody earlier asked me, can I draw my second one below?
No.
That's totally fine if you want to, as long as you have an arrow from the term outside going to each term inside. So since we have 2 terms inside the parentheses, you got to have 2 arrows. Now, I'm actually going to erase my second one so I can color code this a little bit. My first arrow does what? Actually, let's start using cards. So Nick, what does my first arrow multiply together? Because I guess it's obvious. The arrows are multiplication. The arrows are always showing multiplication. So Nick, what does it multiply? A times 2. So the first thing we have here is A times 2. Then there's addition between the 2 of them. So we know that there will still be addition. And then what does my second arrow do, Todd? What does that multiply for me? Is my green arrow up there?
Yeah, that wouldn't that what you call it? Wouldn't you like move the parentheses?
So the parentheses are just gonna disappear after we do this multiplication.
Yeah.
So my first arrow did A times 2. My second arrow does A times B. Yeah. And you can show the dot in between them for multiplication, or you don't have to. Haley, you with us?
Yes, I am. I'm writing everything down.
So then, there's one way we can pretty this up. One way that we like to write things better than it's written right now. Instead of writing A times 2, we would rather write 2A. because we like the number to come in front of the variable, because that makes that number my coefficient. So we have 2a plus ab. And because this is just an a term and this is an ab term, they're not like terms. I still cannot add them. We're done. That's it. No more work that we can do. Try the next two on your own. Now the tricky part is, what do you do with that minus? The first one was addition, so it was easy. What do you do with that minus? I will give you a hint after I capture this if you get stuck. Here's one thing that you can do if the minus is throwing you for a loop. Instead of writing minus 4c, we could write plus a negative 4c, which is what I like to do better, because then I can just use that as a negative and I don't have to worry about it as the minus. So then still, I'm going to have two multiplications. Sam, what is my first multiplication that I do here? My red arrow, essentially.
5 times 1.
Yeah, 5 times 1. Then, because I changed this to addition, I know that I can just put a plus between my terms. So, Reed, what is the second multiplication that happens?
5 times 4.
Now, here's the thing. You might be right if you have a minus here. Because I have a plus, I have to do 5 times negative 4c. So there's two different ways to do this. That's why these get so difficult. And I'm going to show the other way right as soon as we get done solving this. That 4c looks a little weird. 4c. So then, this just simplifies. What's 5 times 1? 5. 5 times a negative 4.
20.
Negative 20. So that's going to be negative 20c. Or this can just be 5 minus 20c. So now I turn it back from being plus a negative. I just make it minus. Because plus a negative value is the same thing as subtraction. Now here's the other way that we could do that.
Did you capture that?
Yeah, it's going. It's just got a lag.
Wait, you're not supposed to find the answer?
There is no answer. All we can do is simplify. So this is the simplified form. That's as far as we can go.
Oh, I did the 20
You
minus
can't.
5.
You can't. Alpha. So I've said this 3 times already today. I need you to listen to me and look at me while I say this. These are not like terms. This is a number. My 5, we know what it is. It's 5. This is negative 20c. We have no idea what c is. I cannot do anything else with that because it's not a like term. I cannot take 5 bananas and add z with it. I don't like that. What am I going to have? 5z bananas? Like, no, you can't. They're not the same sort of things. I can multiply non-like terms, but I cannot add or subtract them. So, here's the other way. If we take it right as it is, hang on to it till I get done showing this. This would be 5 times 1. And then the next arrow would be 5 times 4c, but we're going to take this as a minus. So it'll be 5 times 1 minus 5 times 4c. So then I have 5 minus 5 times 4c gives me 20c, and we're done. That's the other way that we can do it. But that's as far as we can go.
Isn't that easier than the first?
It depends on what your brain thinks.
I think this one's easier.
Now, here's the trouble with what you think, like which one's easier. Now when I have a negative out front, it gets slightly more challenging because I think it'd be easier on my second multiplication, so my green multiplication, I think it'd be easier to do a negative times a negative, which then would give me a positive. So when I approach this problem, I rewrite it as negative 0.2 times 7x plus a negative 0.3. And because I've made my 3/10 negative, I put it in its own parentheses.
When you're like done with this method, can I ask you the way I did it?
I'll come look at yours. I don't want to confuse people. So write out all your work so I can see it when I get there. I'm going to kind of show the work, like where it is. So my first multiplication is negative 2/10 times 7x, which is 1.4x, but it's negative, which my negative just looked weird. My second multiplication is negative 2/10 times negative 3/10. Here's a trick, trap door. Don't fall into it. What's 2/10 times 3/10? 6 what? 6 hundredths. And since this is a negative times a negative, positive 0.06. So now I have these two terms. I have a negative 1.4x, and I have 6 hundredths. Todd. All I do is combine them, negative 1.4x plus 6 hundredths, and I'm done. I cannot add them together because they're not like terms. Questions? I'll show the other way. Mia, did you have a question still? Okay. I thought I might cover it. The other way, if you don't change the subtraction into addition of a negative, if you don't do that, I'm going to run that real quick. My first multiplication, negative 2/10 times 7x. My second multiplication, but now I'm going to use that as a minus. So now it's minus negative 2/10 times, this is now positive 3/10. This becomes negative 1.4x minus a negative 0.06 minus a negative plus a positive. So negative 1.4x plus 0.06. I get the same answer that I had up there. I just got there a different way. Cool. So think about this. Which expressions show a sum or difference equivalent to this? So essentially you can just solve this. So what would be the solution of this when we distribute? I'm going to rewrite it. Try it on your own. We have negative 1/2, negative 1/5 times negative 5m. Hey guys, when we're dealing with a fraction, make everything a fraction. Plus 10, but again. Huh?
This is the God of it.
Yeah.
How do we know what n is?
We don't. That's the whole point. So what was your method? Yeah, that's fine. You just took that as a minus, and then your 0.3 is positive since you took it as a minus.
Yeah, but I got it.
No, you didn't.
I just put the plus because
Then you forgot that that minus and that negative will combine to be the positive. That's what that happens. All sound issues. None. Oh, no. Fighting with pencil. My first multiplication here negative 1/5 times negative 5. Guys, forget about the negatives for a second, because I have a negative times a negative. What's a negative times a negative? Positive. So a fifth of 5. 1/5 of 5. What do you get?
25.
That'd be 5 times 5.
Wait, 1/5 of.
If you have 5 of something and you give somebody 1/5 of your total.
4. You have 1
5.
left.
Hey, check this out. 1/5 times 5 goes straight across the top, straight across the bottom. It's just 1. So here we get 1m. My second multiplication is negative 1/5 times 10, which is really 10 over negative 5. It's really negative 2. So I could do plus a negative 2, or we could just write m minus 2. Me?
I'm so confused with like the first part because I see how you got like a 5 over 1, but then how did you get the 10 over 1?
So 10, like this 10, I can just write as 10 over 1 because 10 divided by 1 is just 10. So because I had a fraction out here, I just made all of my other values fractions to make life easier. We didn't have to do it, it's just easier that way. Other questions? Huh? 1 does not have to be there. It's not necessary. So there is a 1 there, we just don't see it. It's unimportant.
No, I mean like the number 1, the first one.
So negative 1/5 times 10, what would that give you? We just did it. Negative 1/5 times 10. 2. And then negative 1/5 times negative 5m gives you positive m. 1 would also work.
I got it.
You're right, man. Questions, comments, concerns?
I didn't do it that way. To find number 1, I just did like the negative 5 minus the 10. Negative 5 plus the 10, which equals 5, so I did it to 10 minus 5, which equals 5.
So when we look at which of these can be expanded, they both look relatively the same. What's the difference between this expression and this expression? Ty?
In the first expression, negative y has parentheses, and the second one it doesn't.
Yeah, so I think there's something different happening here than what is happening here. What does it tell me to do when I have a parentheses right against another parentheses? Mia? Multiply. So here, I want you guys to draw an arrow up to where the parentheses meet and write multiply. If a parentheses is followed by a minus sign or a negative sign, what is that telling me to do? Alex?
Add?
What sign is that?
Oh, minus.
Minus. So that's telling me to subtract.
Oh.
So that's how this is different. This one would multiply, and we would have to distribute to there and to here. My other one would not. Now I want to review something else that I have to switch back over to digits for. Once that captures. Here's the deal with distribution. We know that we have to distribute when we have a number or a value. I say value because we don't necessarily have numbers. We might have a variable. The most common way we're going to see it is the number is on the left, out in front. We kind of call the left side the front of the parentheses. That's the most common way that you'll see it. However, there are a lot of other ways we can distribute also. This, like what we just saw, if there's something right up against the parentheses, notice, is there an addition or a subtraction symbol in between there? No, that 5 is right against your parentheses. it's gonna multiply. So that multiplies and distributes to both terms. It might be a variable on the left or on the right of it. So if I have a variable on the left, I multiply that into both terms. If I had the variable on the right, it would do the same thing. It would multiply into both terms. On a negative number, it then takes my negative all the way through. So notice I start with -5, there's -5, there's -5. And then it multiplies in with them. But my 2x just stayed 2x. Here, they take the minus as a minus. And the 3 just stays positive then. And then they do the work all the way through. And no matter how many terms there are, you will not see a lot of these this year, but no matter how many terms there are, we distribute to every term in the parentheses. So if there's 19 terms in the parentheses, you distribute and have 19 arrows, each arrow showing a multiplication. This all makes sense?
Yeah.
Questions on any of this? All right, let's hop back over here. So we're going to architect. Here is your current patio. Well, let's just color code this yellow. So you threw a party. Woo, birthday. And you had this much patio space, and it wasn't enough. You ran out of space. All of your friends could not fit on the patio. So you decide to hire an architect to expand the patio, so next year, none of your friends will feel left out. So you decide you're going to add on this section. This is going to be your new section or your addition, but you're trying to decide how big to make it. Can you put your head down, please, and stop turning around? Yeah. You can't have your hood up in school. I know it's cold. It's a dumb rule. I know. So this expression over here, 3.7 times 4.5 plus x, that represents our final new entire patio area. And guys, this is like identical to questions that you're going to have on your homework. So I would advise you to please be paying attention working with us. We want to talk about what does each factor from the expression represent, and then what does the entire expression represent. I kind of already gave that away from you. But 3.7, this 3.7, what is that in this situation? It's the width of the deck, right? So, and you could call it width or length, but whichever one you call it, then your other one will be the opposite or the other term. So since 3.7 was the width, we're saying this is W. What would my 4.5 be? Is Ashley's out today, right? Mr. Besaw, what would my 4.5 be there? The length, right? But it is the original length. So don't just put length. Then we get tricky. What is our x? What is our x? Right? Yeah, you're sitting there. What do you think the x is? Yeah, it's the additional length. So then that expression all together. So we really have the width times the length. The width times the length. Because 4.5 plus the x, that's going to be the combined new length. What does width times length give you? What is that expression representing, Alex?
Height.
Area.
Area. Length times width, or width times length, is area. So this represents the area of the patio. So now we're going to solve this through distribution. So down here I would rewrite your 3.7 times 4.5 plus x. My first distribution will be 3.7 times 4.5. I will have addition between them. And my second distribution is still that 3.7, but now it multiplies by, what's the
Multiply by x.
yeah, it multiplies by the x now. So my 3.7 times my 4.5, someone with a calculator? 3.7 times 4.5? They're kind of goofy numbers.
12.95.
I think you made a slight error.
It's
16.65.
I put 3.7 times 3.5.
What is it? 16 point what?
65.
I got 12.9.
Todd, check what you typed in.
Yeah, I checked the right
guarantee-
position.
It's supposed to.
I put 3.7 times 3.5.
4.5. You gotta pay attention to what you're doing. It's right here on your paper too. That number, the 16.65, is the area of this portion of the deck. The 3.7 times x, well, I can't multiply that any further. I just keep it as 3.7x. That is what, Ty?
That is, I was going to say something different. I was going to say that the reason why we only have one variable is because we're not varying the width or varying.
Right, like
the
this
length,
is
yeah.
staying the same. That's staying 3.7. So this 3.7x is the area of the new part of the deck, or patio, whatever you call it. So now to figure out the total area, this represents my total patio area. Questions? A few problems on your homework give you a situation like something being on sale or something being added with something, and in the situation you have to figure out what do those numbers or variables represent. Alright, last one for today. You're back at your birthday party, planning next year's birthday party with the new patio, big enough for all your friends, hopefully. So, you decide, your friends are probably going to be hungry, it's going to be a long party, you better get 2 cupcakes for every guest, every person you invite. But also, you know that accidents happen, people drop their food, little sister, little brother might come screw with you. So you order 5 extra cupcakes. So, we have 2 cupcakes for each guest, 5 additional cupcakes, and then we find out that each cupcake is going to cost $2.25. So I want you, here right by A, to list out what does each factor represent. We've got the 2.25, we've got a 2x, or you could take the 2 and the x separately if you want.
Isn't that supposed to be 2.25?
Yeah,
So why do you keep saying 2.25?
because either way that we say it like that is not correct. It is actually 2 and 25 hundredths.
Oh.
But the reason I don't say 2 and 25 is then it sounds like an addition problem. So when I say 2.25, it's a little bit clearer. Or,
Oh, okay.
I mean, 2.25 is still correct.
It's gonna be a little same thing in the inside.
Yeah, it's just a little bit more definitive for what you're writing. And it's quicker to say.
I mean, the word is
And then your 5.
okay.
So Laney, can you tell me what the 2.25 represents here?
The cost.
Cost of what?
Each cupcake.
Yeah, cost of each, or cost of one. So every cupcake costs that 2.25. Todd, do you know what the 2x is?
Yeah, I think I might know. This is what I did. So I did 5 times 2.25.
Hold it, you're getting ahead of us. All we're doing right now is identifying what these parts mean.
Okay.
So we're gonna come back to doing what you just said,
Alright.
but you're just ahead of us. Jennifer, what's the 2x mean?
The cupcake, how many cupcakes you gonna get each guest?
Yeah, so those are the cupcakes for the guests, right? So these are like the guest cupcakes.
I put 2 per guest.
Yeah, 2 per guest. That's a really good description too. I'm abbreviating cupcakes as CC because I've run out of board. And the 5. Sorry.
Is 5 additional cupcakes.
Yeah, my extra cupcakes.
Adam.
My contingency cupcakes. You know, for in case something goes wrong. Contingency is like a plan that you make for the what if. So if you're planning a birthday party outside, you might have a contingency plan for rain. Yeah. So now we have to solve this. So now we're going to start doing like what Todd was telling us to do. We've got, I'm going to come over here so I have a little bit more room. 2.25 times 2x plus 5. You guys are probably working down here, but I don't like squatting. My legs are already sore enough. So, do each distribution. I ran a 5K on Thanksgiving morning.
Really?
Thank you very much. Yeah. I like how you like can't believe that. Yes, I ran. My wife made me.
Did she run with you?
Yeah. She didn't make me. She told me that I should, and she was right. I should.
Because all that turkey is good.
Right? All that turkey.
Every
All right.
year.
What, Mr. Isel? Sorry, can you see, bud? I just realized you're scratching your eyes. What's the first distribution tell me to do? What's that multiplication? The red arrow. Yeah, what about them? Well, they can when we're multiplying. So that's this red arrow tells me to multiply my 2.25 times 2x. I have addition between them. My blue arrow, Ty.
Blue arrow is 2.25 times 5.
2.25 times 5. Colin, what do I get when I take my 2.25 times 2x? So here, bud, try this. Yeah, 4.50 or 4.5. So 4.5x, my x has to stay on there. Plus 2.25 times 5. Nick? 11.25. And that is as far as I can solve this. If you know how many guests you're inviting, then we can take this further. So, real quick, give me 20 seconds just to talk through why this situation matters. If then you told your mom, hey, I want to invite 10 people, then you would plug in a 10 for the x. You'd then get 45 plus 11.25 and be able to figure out your cost from there.
Why would you invite 10 people to a birthday party? You just fixed up your floor.
So I'd invite a lot of people.
Yeah.
But all right, that's all I have for you guys today. Homework is posted. I think it's only like 11 or 12 questions.
What is this?
Every
It's an expandable like divider thing.